So good morning, good afternoon to all of you, and thank you for coming to the fourth Community Consortium, also known as CCC Community Chat. We are excited to take this opportunity today to share the output of our recent release, Envisioning Possible Futures for AI Research white paper, with all of you. The webinar is scheduled for 30 minutes, but the co-authors are available to continue answering your question and discuss with you for an additional 15 minutes until 2:15 p.m. Eastern Time. The Q&A is now open. If you want to submit any question, they will be answered at the conclusion of our speaker, David's presentation. My name is Michaela Taufer, and I am an executive committee member of CCC Council. CCC is funded by the National Science Foundation, and we run visionary exercises on a wide range of interdisciplinary topics in computing to catalyze the future of computing. As you may have seen, if you hoped on a little bit early, right now we have two ways that you could get engaged with CCC, and we are always looking for new volunteer. First, CCC as an open call for visioning proposals. If you have an idea of a computing research topic that CCC could help catalyze through a visionary activities, for example, a workshop, please propose it. There is a link in the chat to CCC webpage with more information and a link where you can submit your idea and complete a submission form. The second way to get engaged is through CCC, which currently accept nomination for council members. If you are interested in serving on the CCC Council or know a colleague who could be a good fit, please submit a nomination. Now there is also a link in the chat to the CCC webpage to learn more. So CCC is funded by the National Science Foundation. Our mission is to enable the pursuit of innovative, high-impact computing research that aligns with the pressing national and global challenges. In pursuing our mission, we engage in a wide range of events, products, and communications in collaboration with members of the computing research community, people like you. As I mentioned earlier, we accept proposals for visionary activity, like workshop. We also have council-led activity and are reactive to the need of a broader community in computing. I just have one more announcement before I introduce our speaker. We would really appreciate if you please take 1 minute after we end the webinar to take a very short survey that will pop up on Zoom. If you do so, it will help us tremendously to make this event as beneficial to you and the community as possible. Last, I want to introduce the lead author of the Envisioning Possible Future for AI Research white paper, David Jensen. David Jensen is a professor of computer science at the University of Massachusetts, Amsterdam. His research focuses on machine learning, particularly causal inference, explainability AI, and method for evaluation of machine learning algorithms. From 1991 to 1995, David served as an analyst with the Office of Technology Assessment, an agency of the United States Congress. Thank you for joining us, and thank you for being here, David. You have control.
Very good. Thank you, Michaela. Greatly appreciate that introduction. Well, welcome everyone. Thank you for tuning in to this, our first of these this variety of ways of talking about the products of CCC. Of course, today I'm going to be talking about this white paper, Envisioning Possible Futures for AI Research. And, I want to make really clear, I'm speaking today, but this was an enormous team effort from the members of the council and the CCC staff. And the authors are listed here, and almost all of those authors are here today to answer questions, and that's really wonderful. So clearly, an enormous amount of the attention that we see today directed toward artificial intelligence is directed toward technologies like deep neural networks, large language models, visual language models, other kinds of large neural network systems. But I want to make sure that we view the current moment in context. That is, in the history of how artificial intelligence has developed, and with the knowledge and context that many various paradigms of AI research have been hailed in previous eras as what we need in order to bring about something like artificial general intelligence. And so while many of these paradigms are now viewed as sort of outdated and say, oh, well, that was then, this is now, we need to look at the current moment and realize, of course, that there's going to be a future, a next thing for AI research, and on the right side of this timeline. And really that there is a surprising amount of uncertainty that we might have about what that future is going to look like and what combination of technologies and capabilities that future might rest on. So with that kind of context, that's what brought about our interest in writing this white paper and studying this topic. So really the fundamental questions that motivated our work over the past year or so leading up to the white paper was what's next for AI research. That is what comes after the current era that we have of deep neural networks and foundation models. So we felt it was important to concentrate on this topic and spend some time thinking about it and soliciting opinions from the AI community. First of all, to aid the future of AI research, to try to provide concrete visions of what alternatives might look like, not because we think that they're going to happen, but because it helps people, current researchers, look into the future and say, okay, we need to think big. We need to look at what the next AI revolution might consist of, particularly for younger researchers who have grown up largely within only a limited paradigm that we have right now. A second reason was to inform policymakers, many of whom are unfamiliar with AI past the current boom. And they're, in some cases, thinking, well, AI research seems like it's done except for the scaling. Can't we just basically call it done and say we don't need to further AI research? And finally, I think to emphasize the role of federal funding in supporting research that will lead to the next AI revolution. So what we did was to seek input, and in particular, what we did was host a set of roundtable discussions with more than 20 AI researchers who are AAAI fellows during AAAI 2025 and after. And also, it's worth noting that the co-authors themselves are a pretty broad swath of AI researchers. And so we took that input from AAAI fellows, and then we talked a great deal among ourselves, wrote and rewrote, and came up with the white paper that we released in the summer. This is the list of the co-authors, and as I said, many of whom are here today to answer questions. So part of our work was to come up with what we really thought was and meant by the term AI research future. We wanted to identify relatively unified and what I would call kind of bounded paradigms of research. That is, if we identify one of these, it should be evident what's in and what's out of that particular paradigm. We also wanted those paradigms to be motivated by specific technical issues, and that can either be shortcomings of current systems or also emerging technical possibilities that might lead to a new kind of AI research. I want to emphasize that we wanted those futures to be possible, but not necessarily likely. Obviously, we can't predict the future. We're not trying to, but instead we just wanted to provide a set of options to make concrete what we're talking about when we say an AI future, not because we think that a particular one of those, or even necessarily some combination of those might actually represent the future. And finally, and this is a particularly important one, we wanted to describe not just future capabilities we wanted, but how a research paradigm might credibly produce that new capability, what we refer to here as means and ends. We didn't just want to talk about ends, we wanted to talk about means. And so many of the paradigms that we're talking about here aren't just a neat thing we want AI to do, but instead a way that you might get there. So this last one, I think, is somewhat unusual, but as we talked about, these became pretty important. So we came up with, in the white paper, a set of AI research futures that I'll talk about briefly here. There's a lot of detail in the white paper. The first is one that is talked about a lot within the AI community, Neuro-Symbolic AI. That is a way of merging the current approaches of neural networks with something traditionally that is somewhat older tradition of symbolic AI to try to get the benefits of both. We also identified quite a chunk of research that is around neuromorphic AI, that is computational hardware whose actual physical structure mimics many of the capabilities and structure of neural tissue. This is particularly interesting because it can produce extremely low power computing. We also looked at embodied AI. This is moving beyond the kind of current paradigm of sort of what's sometimes called brain in a box to one which interacts with the physical world because there is some reasonably good evidence in thinking that physical interaction with the world really alters what it is possible to think about. Multi-agent AI is certainly something which is being explored currently within the current paradigm, but also has a long history and really quite possible future capabilities of how to get multiple AI systems to interact in meaningful and interesting ways. Next, we looked at human-centered AI as a way of really emphasizing augmenting of human capabilities rather than mimicking or replacing human capabilities as a way of thinking about a different way of thinking about what AI technologies can really be. Finally, we would probably be remiss if we didn't identify quantum AI as a possibility, still quite speculative, but another example of a very different place that future AI research might go. Now, also, in addition to these, we have a section in the white paper discussing additional future developments in deep neural networks, which we think are quite likely and will certainly are likely to form part of the future of any sort of AI research paradigm. And I want to emphasize this was not intended to be an exhaustive list. Instead, we were trying to call out these futures to provide concrete examples of the kind of thing that we were talking about in the white paper. The last thing I want to mention before we move to questions is just some kind of context and some implications of this. Much of the work that's going on in industry right now is really intensely focused on exploiting the current revolution in AI, rather than asking what comes next 10 years from now or 15 years from now. This tends to be the domain of federally funded R&D that is really supporting a range of options that can form the future revolutions in artificial intelligence rather than exploiting the current one. And that has certainly in the United States led to some really substantial national benefits of being able to be first in a variety of technological revolutions, the current AI revolution being one of those. And so there are serious benefits to that long-term federal support of research and development, typically at universities, but not exclusively there. And finally, we wanted to point out that it is not immediately clear that US-trained researchers and US-based companies will lead the next AI revolution. That would be possible if there was substantial federal support for future, for exploring these possible futures. But that is an open question about whether the next AI revolution will be centered in the US. And with that, I will turn it over to Peter, who can say a little bit more.
All right, thanks so much for that great presentation, David. Before we dive right into the audience questions, I want to introduce the other AI experts that we have with us here today, that we're all co-authors on the AI Futures white paper. So other authors, if you could go ahead and turn your cameras on, and I'll introduce you. We have David Jensen, who's a professor of data science, philosophy, and policy at the University of California, San Diego. We have Sebastian Elbaum, who's a professor of computer science at the University of Virginia. We have Mary Lou Mayer, a professor of computer science at the University of Sydney. Bill Regley, professor of computer science at the University of Maryland at College Park. Matthew Turk, who is a professor of computer science at the University of California, Santa Barbara. And Holly Yanko, who is a professor of computer science and mechanical and industrial engineering at the University of Massachusetts, Amherst. So we're super fortunate to have everybody here to help answer your questions. So we're going to move to that Q&A portion. I ask you can use the Q&A app in Zoom to submit questions. And if you see questions that others have submitted that you think are definitely worthy of an answer, please go ahead and upvote those, and those should rise to the top. But we did also ask all of our registrants if they had questions when they registered, and we did have a lot of submissions. So we went ahead and tried to synthesize, maybe using some artificial help, to grab some of the most common themes that were brought up in those questions. And so I want to start with two of those submitted questions. The first one for our panel is, what is the essential, unique role of academia and university research in the future of AI, given the vast investment and rapid pace of industry-led development? So I see David's got his hand up first, so that was quick.
So, one of the things that I think universities have traditionally done very well is really to be looking out further than current industry is, for lots of very good reasons, and particularly given the intense competition we have right now in the industrial sector. I think there's an enormous amount of pressure on extremely talented people in industry to focus on very near-term advantages. What can we do right away to make the current systems better? And we're not getting the focus that I think we've traditionally had in the community on the longer term questions of where AI might be going in, say, 5, 10, 15 years.
David, do you want to build on that?
Sure. We'll keep the David theme rolling along here. I think David Jensen focused on the time scale. I also think that academics are in a position to investigate questions for which we have perhaps never any financial payoff. We don't have to adhere to the same sort of business models that have to happen in industry. You don't have to be able to show a return on investment in a financial form. And so I also think that's an important distinction, because sometimes there are very near-term questions where there's no financial payoff. There are long-term questions, which of course also have a very risky ROI for industry, where academics again can play a role. And so it's not just one very narrow lane for academics. It's rather, I would suggest that industry has a fairly narrow lane of things that they are in a position to do. And as academics, as many of us on this call are, we have the freedom and ability to stray very far from those lanes in positive ways, whether for national interests or research and intellectual interests.
Matthew?
Yeah, so just as a subset of that, really, the opportunity to do interdisciplinary exploration and collaboration and research is an example, I guess, of what David was describing, that it's much harder to do in industry, getting the perspectives and working with neuroscientists and psychologists and philosophers and humanities people and a whole range of people who will bring things to the table that you're not as likely to find in typical industry scenarios.
Okay, I think this is working. So let's try the second synthesized submitted question, which is, how can we build and ensure the safety, ethics, and reliability of next generation AI, especially LLMs? And what role might methods like Neuro-Symbolic AI play in achieving these goals? And Matthew, your hand is still up, but I don't know if that means you want to answer this one. Okay, so Sebastian.
Yeah, hi everyone. Thanks for joining us this afternoon. I think the report emphasizes Neuro-Symbolic in several ways, but I think that's one of the key mechanisms to ensure at least the safety and the reliability of the LMs and any Gen AI that we're creating. I think what we focus on are at least three aspects or three areas to work on. One is correctness, the ability of having these Neuro-Symbolic approaches offer us new ways to check for the correctness of the networks. And there are a lot of mechanisms that are already emerging in this area, for example, to reduce hallucinations. But we see this as the beginning. I think there's a lot of opportunities to integrate automated reasoning, for example, once we have those symbolic representations in place together with the neural ones. The second aspect is our ability to generalize. And I think the Neuro-Symbolic offers us a way to do that beyond the training data set by combining logic in interesting ways. And the last part about the reliability and I think safety is about understanding and explainability. And I think the opacity of some of these models could be reduced through the incorporation of these Neuro-Symbolic approaches. So those are three areas that we focus on. In terms of what David Jensen was mentioning in terms of means, how do we get there? I think that our section on Neuro-Symbolic really focus on integration. The idea that right now the integration of Neuro-Symbolic is rather limited. We're scratching the surface of what we can do, and part of the integration runs at all levels. So we're talking about integration of data sets that include, symbolic elements in the data set. We're talking about architectures that have both elements integrated. And right now, those integrations are a little bit rough and sloppy, and there's not a universal way for us to put those together. And I think, data sets, architectures, and tooling to actually bring those spaces that are, integrate them nicely together is a research direction that we emphasize in the report to give us some of those safety and reliability goals. Thank you.
Thanks for that, Sebastian. David.
Yeah, I would just briefly add that I think, obviously there's been an enormous amount of discussion about safety, reliability, security of things, as the question that you posed, Peter, asked about things like LLMs. I think one of the things that's striking about some of the futures that we're discussing is we don't actually know very much about whether these would be safe or reliable or what it would take. If we just think about the intense investment of effort, both in research and development, to have safer, more secure LLMs over the last 4 to 5 years, we haven't seen that in something like Neuro-Symbolic. We haven't seen that in something like embodied AI to the same degree. Obviously, AI and robotics, there's been a lot of focus on safety and security as well. And so I think one of the things that the report raises is that it isn't just about the sort of raw power or accuracy or performance of these systems, but we do need to, when we're thinking about AI futures, think about exactly as you said, which ones are going to be safer, which ones are going to be able to better support the needs of people, and not just which ones look really good in a chart.
Thanks for that, David. Okay, I'm really eager to jump into the live questions here. And please keep upvoting these as you see them appear. The currently highest rated question at the moment is from Mark Bomedine, and it is an important aspect of the future could be sustainable AI. Do you have any discussion on this issue?
I'll go ahead and jump in. So, I will say that sustainability, particularly energy usage, which is, what a lot of attention is focused on right now on LLMs, was one of the motivating factors for neuromorphic computing. That the, extraordinarily low power requirements, but also that many of the alternatives, the futures that we identified, would have both either the capability to reduce energy requirements or essentially the need to reduce energy requirements particularly if you have, for instance, embodied AI that is separated from a network. You need to have onboard computing, and you have serious power limitations. So that is not explicitly discussed in the report. Sustainability is an end, and not really so much a means, but the means that we talked about included, for instance, neuromorphic computing.
All right, thanks, David. Next highest rated, maybe isn't so much, maybe it's a rhetorical question, but it's worth saying, from Vasant. A comment on industry versus academic research. Where will industry get its AI researchers from if they are not being trained in academic research settings? Good question. Matthew.
So to be fair, I mean, I think that's an obvious question and a concern everybody has probably, but to be fair, things have changed a little bit over the years. So it used to be that you needed a PhD to have the expertise to work on, AI systems. That has been pushed down a bit. So there are a lot of undergrads these days who have significant expertise. So it's still a valid question, still a concern about the overall pipeline, but it is a little different. There's some nuance there.
Fair point. Sebastian.
Yeah, I agree with Matthew. I would add, though, that for those critical positions that you do need someone trained that knows the latest and the greatest developments, I am not sure where that expertise is going to come from. And I think what I would highlight, though, is that the pain of not having access to that expertise is not going to be felt today because of the pipeline of students and researchers that universities are producing. The worst thing about this is that the companies are focused on the short term, may not see this pain coming up in 2 or 3 years when our pipelines get empty. And at that point, it's going to be too late to realize that, or it would take a few more years to restart those pipelines to the point that academia can actually provide adequate production to fulfill those positions.
Thanks, Sebastian. David, do you have a
I want to use this question as a bit of a jumping off point also to say that I think one of the most important roles for academia is actually doing the science necessary to do good engineering in industry. That today we have, perhaps for the first time in AI, systems that are so complicated we really have no idea how they work. And there's a lot of work in industry, but frankly, there is more than enough work to go around trying to understand how these systems work. So that's not so much a issue of personnel as an issue of knowledge that will allow the personnel in industry to actually engineer future systems that have the capabilities we want.
Okay, the next highest rated question, it comes from an anonymous participant who asks, could the panelists please comment on how they envision the role of open source in the AI futures presented in the white paper? I ask this question with the iterative development of open source large language models in mind. Thank you. Who wants to take that one? David.
I'll take a stab at it. I mean, I think, open source, we now have quite a bit of evidence that open source is really important in terms of stimulating innovation and can really be an accelerant when it comes to research. I do think that a challenge we have is that in general, researchers are not necessarily incentivized to produce things in an open source way. If I have some new algorithm that enables me to get much better performance on something, as an academic researcher, even as a researcher, I'm not trying to make a company out of this, I have some incentive to not necessarily fully open source the algorithm, at least, in the early days. It's getting better in terms of the social norms within the AI research community. But I do think there's a bit of tension, which is we know that open source benefits the community, but it doesn't always benefit the individual who produces it. And so I think that this is something where we need to find ways to further incentivize open sourcing of software, of algorithms, of ideas, so that we can actually take advantage of the ways in which it can be an accelerant.
Mary Lou. You're muted, Mary Lou.
want to complement the answer that David provided to point to the National AI research resource that NSF is making available. It is not quite the same as open source, but it does democratize the access to the kinds of resources that AI researchers will need, where it doesn't cost money to access or to use fairly large systems, large data models, and large data sets. Again, not open source, but available to anyone.
Thanks, Mary Lou. Another participant question, this one on education. How can we effectively bridge the gap between advanced AI research and education? When emphasizing the development of US trained researchers, PhDs, masters, undergraduate students, how can we ensure that the education system and curriculum keep pace with rapid research advancements? And David.
Sorry, I just keep jumping in on these things.
Others can answer too. Yeah.
Nature abhors a vacuum, and I guess I do too. I would call right back to what Mary Lou just said. NAIR, the National AI Research Resource. An enormous part of the NAIR is an effort to build out resources that can be used in educational contexts. How do we help make sure that the next generation understands how to use high performance computing, and in particular, how to use high performance computing for AI purposes, including the most advanced algorithms? There are a number of other efforts that are underway. Here in California, a bill was recently signed to create CalCompute, which would be a primarily education-centered effort to have large compute resources, particularly around AI, available to community colleges and state universities. I think we're going to see more and more of this happening, where one community college, all they can get is 10 GPUs, which may not be enough, but get together 20 community colleges, and all of a sudden you have 200 GPUs, which is enough that you can start to help train the next generation in that. So I think that doesn't necessarily help with the research side, but it helps make sure when we're thinking about workforce that we have people with the appropriate knowledge and skills.
Thanks, David. Holly?
I'm currently at the NSF AI Institute's meeting, and we actually had a whole meeting yesterday about how we could share educational materials that are being developed in each of the institutes. So right now, all of these efforts have been very siloed, but we're looking at better ways to bring them together and bring them out. So all the institutes have been developing things around K-12 education, community colleges, undergraduate and beyond, and workforce. So we're also trying to find a way to make the whole much greater than the sum of its parts with all these outputs from NSF-funded projects.
Thanks for that, Holly. We have a question now from Jeff Heflin, who asks, given the almost impossible public expectations around LLMs, for example, AGI in a few years, what is the likelihood that industry leaders and policymakers will become disillusioned with AI, leading to another AI winter? Your report seems like an attempt to educate to avoid such a future, but what else can we do to prevent the next AI winter? It's a good question. David.
Yeah, I will say it's a very good question, and I'm glad that the questioner saw that in the report. That is certainly sitting in the back of our minds. And one thing I will say is my own personal impression. None of us can predict the future well, but my own impression is that there are large numbers of really effective uses of current AI technology that are quite realistic. There certainly are inflated expectations. There's no question about that. However, that's not necessarily the expectations are all not necessarily positive right now. There are some seriously negative expectations that the public has that about AGI in a few years that perhaps will bring a degree of relief if and when that future does not arrive. That people may actually be happy that we are not getting AGI, but we are perhaps getting some other useful capabilities out.
Bill.
I'll just add to David's comment. There's a quote from David Lynch when he passed that we can't look at the donut, we should keep our eye on the hole. And I think there's a very large distraction that's occurring societally that's really taking our minds off of where the real problems lie. So I don't think there's a lot we can do to prevent trillions of dollars of investment from swinging one way or the other. But us, as mostly academics here, need to figure out what the hole is rather than focus on the donut. And personally speaking, that's kind of been my challenge in my return to research, is figuring out what's worth working on without getting distracted. So I think our report sort of kind of tries to incentivize that.
Thanks, Bill. Another question from the participants. I'm specifically curious about embodied AI. Would you think this will go beyond CS, CSE, EE, and become part of all general applied computing fields? Holly, right to it.
Right. Well, it's embodied AI. I'm going to answer the other question too, also on embodied AI at the same time. That's in the Q&A. As a roboticist, I truly believe that there's a lot that robotics has to play in the role of embodied AI. And I think that, one of the interesting things as we're starting to think about embodied AI is, where are these data sets coming from, and how are we creating them, and how in creating those data sets are we introducing bias into our very training there? I think that we have a lot to learn about generalization, not only in environments, but across all of the multiple embodied systems, all the different types of robots that are out there. So I think it's a big open field, and I think it is broader than what we're seeing in deep learning right now. There's been certainly a lot of success in foundation models. I don't think that foundation models will solve all of embodied AI. I do think that there's a mixed model approach still to be had there. But there's a lot of work to be done just in terms of how do we come up with data in a way that, we had, I don't want to say all the text was free data. Certainly it was created by people, but getting data that's related to robots and embodied AI is a very different problem.
Thanks, Holly. Mary Lou?
Yeah, I just want to add to Holly and just comment that often as AI researchers or as computer scientists, we think that we are solving the problems and that is our problems alone. And I think what this question points out is that maybe the future of AI is not only in the realm of computer science, and embodied AI is a paradigm shift. It's not just looking at how AI and robotics now merge into a future, but more opening it up as thinking differently about what do we mean by AI and what does it mean for AI to actually get out of the box. And I like the question because I don't think computer scientists can do this alone.
Good point. Let's see. Could you comment, all of you, comment about potential overlap between neuro-symbolic AI and neuromorphic AI? Can neuromorphic or neuro-symbolic methods be more easily integrated into hardware? David.
One of the things that I think is I don't know, 100+ year now problem in cognitive science and neuroscience is exactly this question of how do you integrate neurosymbolic and neuromorphic, right? How is it that the squishy gray stuff in our skulls that we know is highly distributed and highly parallelized nonetheless is able to act as though it is doing some sort of logical symbolic computation? So I think right now that's a giant open question. We have various theories on hand, but none of them that actually seem to work fully for humans, and none of them that are working well for machines. I do think that the question is on the right path in thinking about implementation, and that both neurosymbolic and neuromorphic are likely going to be much easier to implement in certain kinds of hardware. Not necessarily the kind of hardware that we're all used to seeing, but hardware that is very much under development. So that's part of why we pose it as AI futures, is because we think that there's a lot of promise in each of those approaches and perhaps even the integration of those two approaches. But we aren't there yet. There's still a lot of open questions to be tackled.
Thanks for that, David. So we're approaching our hard stop, which is at 2:15. So we might have time for another question, depending on how verbose you all are. So let's try with this one, which is how can researchers in academia be funded / incentivized to pursue the science necessary to push these AI frontiers, especially given the current fixation on language models in both industry and academia?
Well, I will just point out that one of the motivators for this report was, in fact, trying to sketch out those futures and say to particularly young researchers that are just coming into academia or industry, there's a big world out there of possible options, even though you may not have seen anything beyond a certain relatively narrow slice of what we now call AI. But providing incentives, I think, means that we're going to need a sort of larger range of both possible funding sources that says, yes, this is the right thing to be exploring, and interest in applications. And I think those are difficult things to get in the current environment.
Mary Lou, last word. Almost
Yep,
last.
I just want to point out that not all incentives are financial, and that people who are at universities who think that some of these ideas are good should share the white paper, spread it around, give it to your undergraduates, give it to your new PhD students. Curiosity itself is an incentive. And what we're trying to do here is to reach people at all levels. We are interested in funding agencies and industry, appreciating the importance of these futures as an alternative. But you, as academics, those of you who are in the audience, share this. That's an incentive itself.
I think that's a great point to end on. Thank you so much to the panelists, not only for participating today, but also all your work on the report. Thank you for all the participants in the audience. We really appreciate your interest and hope you'll continue to stay engaged with CCC. It would also mean a lot to us, as Michaela said at the very top, to take the brief survey that you'll get from Zoom after you log off of here. Other than that, have a great day. Thanks to you all for joining.